Hello, you are listening to Pankaj Rai, and in this video we will be discussing numericals of the chapter Electrochemistry. We will be discussing the numericals of Faraday's law of electrolysis, and for that the first topic which we have to learn is the mole ratio. Okay, so let us concentrate on what is mole ratio. Now mole ratio is actually defined as moles of product formed divided by moles of electrons required during the half reaction. Now what is the half reaction? Okay, now let us try to understand the mole ratio by taking an example of sodium ion. Now sodium, as you know, have one electron in its outermost shell. Let's say it loses one electron, so it will become a sodium plus ion. It will acquire a charge of +1. Now let's say one electron is added to the sodium positive ion, so it will give us sodium atom in elemental form. Now as you can see here that we have one sodium atom being formed and it requires one electron. So similarly I can say that for production of 1 mole of sodium we will require 1 mole of electron, and that's how we will get the mole ratio. As we said, mole ratio is number of moles of product formed. So if let's say 1 mole of 1 mole of sodium plus ion is taken and 1 mole of electrons are taken, so we will have 1 mole of sodium being formed. So in this case the mole ratio for this will be 1, because number of moles of product form is 1 and number of moles of electron required will also be 1. Now the atoms or elements which follow the same mole ratio will be potassium, because it is also +1, and silver because it is also +1. So just in case if you are having reactions concerning potassium and silver, you have to write the same reaction. Mole ratio for them will be 1. Now let us move ahead with another example. Let us go to magnesium. Now magnesium is having a charge of +2, magnesium ion. Let's say for making a magnesium atom we will have to add 2 electrons to this and we will get the magnesium ion. Now as you can see that for one magnesium atom for formation of one magnesium atom I am requiring 2 electrons. So similarly for 1 mole of magnesium atom we will require 2 moles of electron. So in this case the mole ratio will be number of moles of product, that will be 1, and number of moles of electron, that will be 2, so that will be half. So mole ratio is half. Now the atoms or the elements which will follow the same reactions are calcium, it is also +2, copper, it is also +2, zinc, it is also +2, and barium, it is also +2. Actually there are many elements, but we are taking only those which are usually asked in our syllabus. Now moving ahead with the next one, as you might be knowing that aluminium is +3, so the mole ratio for aluminium will be 1/3. So I'm skipping that and moving ahead to halogens. Okay, now let me take a halogen. Let's say I'm taking chlorine. Now what is chlorine? Chlorine is having 7 electrons in its outermost shell. Let's say it gains 1 electron, so it become a chlorine negative ion. Okay, and this chlorine negative ion will release 1 electron and it will again get converted to chlorine atom. So chlorine negative ion will release a chlorine atom plus a electron. Okay, but wait here, this is not a stable reaction because chlorine does not exist in elemental form. It will directly or very soon reacts with another chlorine atom to form a chlorine molecule. So let's say there is similar reaction going on with another chlorine ion which is giving us chlorine atom plus an electron. Okay, so these two chlorine atoms will combine together to give us chlorine molecule. So what will happen? What is the total reaction? So total reaction says that two chlorine negative ions will give us one molecule of Cl2. These two will combine to give us one molecule of Cl2 and we'll get two electrons. So what about the mole ratio here? Mole ratio, as we said, is the number of moles of product formed upon number of moles of electron required. As you can see that here one chlorine molecule is forming, and for that we are requiring two electrons, or we are getting two electrons. So for one mole of chlorine to be formed, we will have 2 moles of electrons. So mole ratio for this will be half. And all the halogens, the fluorine -1, bromine -1, and iodine -1, they will follow the same mole ratio. Okay, so that's the first part that you should be aware of. What is mole ratio? Okay, now let us move ahead with the theory for numericals. Let us start with charge. What is charge? Charge is denoted by letter Q and the unit of charge is coulomb. When you write the complete name, it should be starting with a small letter, and when you write only symbols, so it has to be capital. What about current? Now current is denoted by letter I and its unit is ampere or A. What about time? Time is simple. The symbol is small t, unit is second or small s. Now how they related? We know that current is defined as amount of charge flowing per unit time. So current is charge upon time. So I can say that I is equal to Q by T. I can also say that Q is equal to IT. Okay, so this is the first thing which you should know. Now the most important part of this topic is another unit of charge, which is Faraday. So let us concentrate on that. Okay, now what is Faraday? Faraday is another unit of charge. Let's say we are having charge which is denoted by Q, but there is another unit of it which is Faraday, capital F. And what is Faraday? Faraday is the amount of charge of 1 mole of electron. The charge which 1 mole of electron possess is called as 1 Faraday. Okay, so that 1 mole of electron will be possessing a charge of, let's say we will have charge of 1 electron multiplied by number of electrons in 1 mole. So that will be the total charge of 1 moles of electrons. So that will be equal to charge of 1 electron. We are aware that it is 1.6 into 10 raised to minus 19 coulomb. And how many number of electrons are there in a mole? Okay, number of particles in a mole is basically the Avogadro number, which is 6.022 into 10 raised to 23 number of electrons per mole. Okay, now when we multiply this, we get 96473 coulombs per mole. That means 1 mole of electron contains a charge of 96,473 coulombs, and this is actually equated to 96,500 coulombs per mole. So here we have a relation between Faraday and coulomb. So we say that 1 Faraday, okay, now we are having a 1 Faraday is actually equal to 96,500 coulombs per mole. So this is a relation between coulomb and Faraday, which you should be knowing. Now having done this, we will be moving ahead with the topic of Faraday's first law of electrolysis to solve numericals. So just now we saw that 1 Faraday is actually the amount of charge per mole, and we saw that 1 Faraday is actually 96500 coulombs per mole. That means 1 mole of electrons contain a charge of 96,500 coulombs. Okay, so let's say I'm having charge, let's say I'm having a charge q coulombs. Okay, so how many number of moles of electrons would be there? That's the question. How many number of moles of electrons would be there? So that formula is given as number of moles of electrons is equal to the charge which is given in coulombs divided by 96,500 coulomb per mole. So eventually this will come out to be q by charge is q by 96500 moles. So this is a very important formula which gives us the number of moles of electrons if q amount of charge is passed. So number of moles of electrons when q amount of charge is passed is given as q upon 96500 number of moles. Okay, now let us move ahead. Now suppose that we have been given that I amount of current is flowing through t seconds. Okay, so obviously by this data we can calculate the amount of charge q, and by calculating the amount of charge q and dividing it by 96500 we can get the number of moles of electrons which are passed. So after getting number of moles of electron passed, we can actually find out the number of moles of product being formed, because let's say, let me take an example. As we have seen just now that Mg2 plus combines with 2 electrons to give us Mg atom. Okay, so if you remember, the mole ratio here was half, that is number of moles of product formed upon number of moles of electrons, so it is half. So that means for 2 electrons 1 mg is being formed. So let's say I is given, t is given, so we can find out charge, and after charge is found out we can divide it by 96500, so we'll get number of moles of electrons. Now number of moles of electrons, let's say we are having 20 moles of electrons will give us 10 moles of Mg. So I can say that number of moles of product, number of moles of product formed is actually the number of moles of electrons multiplied by the mole ratio. So once we have the number of moles of electrons, so the moment we multiply it by mole ratio, so we will get number of moles of product formed, and after getting the number of moles of product formed we can find out the mass of product formed, and it is given by mass of product formed is actually the number of moles of product formed, number of moles of product formed multiplied by molar mass of the product. You should be remembering the molecular mass, or it might be given to you. Okay, now number of moles of product formed, that will be in moles, and molar mass will be in gram per mole. So it is gram per mole. Let's say gram per moles. So moles will get cancelled, and the mass of product we will get in terms of grams. Okay, so by using this concept you can find just what they will be giving you is that they will be giving you current and time. Okay, and you will have to find the amount of product which is formed. So once they give you current and time, you find the charge, and after you get the charge you use this formula to find the number of moles of electrons formed, and you have to write a reaction, and number of moles of product formed will be equal to number of moles of electron into mole ratio. And once you get number of moles of product, so mass of product is moles of product multiplied by molecular mass, so it will be number of moles of product formed in moles multiplied by molar mass in gram per mole, so you'll get the mass of product in terms of grams. Thank you very much.